Okay, this video is 3A. I'm going to divide it into two parts, so it'll be two videos, part 1 and part 2. Part 1 is going to be on the organization and introduction of matrices, and part 2 is going to be on the multiplication of matrices. Now, let's talk about what matrices are, because this is probably one of the first completely new topics that we're going to work on in this class. Matrices is a great way to organize data. And the reason why we do that is because we want to use calculators to number crunch all the math for us. So, but obviously calculators don't understand how to do algebra, but they do understand how to basically add, subtract, multiply, and divide numbers very well. Okay, so our objective is to organize data into a system so the calculator knows how to treat those numbers, and then the end result will be what we want. And it's the same thing with algebra. Algebra, the purpose is to find the unknown. So the cool thing about this is, it's like almost doing algebra without variables. Okay, and as far as organizing data, we focus more on positioning and organization, and not so much what the variables are. And the good thing about this is it's very flexible, so if things change, you simply change one number in the system, and the calculator just recalculates, and no wasted time. All right, so let's take a look. This is the 3x3 system that we looked at in the last video, and we saw it was an enormous amount of algebra work just to get one solution. So how can we organize this data? So let's kind of highlight what we see here. Now notice everything's in standard form. So let's go ahead and write that right here. Everything's kind of in standard form, and the way we like that is because then it's all organized, meaning we have x's in front, and then we have y's behind it, then z's, and then we have numbers over here. Okay, and notice the other things that we have is we have an x, a y, and a z. So those are the unknown variables we have. So let me just go ahead and look just at the coefficients of the yellow here. So I'll do it here in black. So if I look at just the x's, I have a 4, a 1, and a -1. So here's the 4, 1, -1. Then let's look at the y. So I'm going to make a whole new column of the y values. So we have 5 y's in the first equation. We have -3 y's in the second equation, and then 2 y's in the last equation. Then in this equation here, we have z's. So I'm going to make another column. So we have 3 z's here, 2 z's here, and -1 z's here. Now let's go ahead and label this. So over here, the 3 rows are the equations. Okay, and then over here we have the different variables. Okay, so I'm just going to abbreviate there. So what we've created here is a matrix. And I put these brackets along the side to show what a matrix is. Okay, so that's the notation for it. Now we need to tell what these variable columns are. So I'm going to make another matrix next to it. And this one I'm going to kind of switch. This is on top. I'm going to put it on the side here. And I wrote a little example here. Just kind of had it appear. And this kind of shows you why we do this. If we're converting from feet to inches, and we start with feet, we put feet on the bottom so they can cancel each other out. We want them to be opposite so they cancel each other out, and we're left with inches. Same thing with matrices. We want variables to cancel out. And in the end, what we want is we want equations, okay, what we started with, and then what we're going to end up with is what this title is. So this is like the total, okay? And that's the total, or the sum, I guess I could say. So very simply here, what variables are we using? Well, the first column is x, the second column is y, and the third column is z. Okay, we'll talk more about why this is, but I'm just showing about how we can organize. So notice this matrix here has no letters in it, and this matrix here controls the letters, and this matrix over here controls the sums. So let's take a look. What's the first equation? 15. Sum, so I'm looking at these numbers here. The second equation, the sum is -6, and then 3. So let me just go ahead and label what I have. We have first equation, second equation, third equation. We can see that here. And then we have the x column, y column, z column. So then that's the x, obviously, the y, as we can see there. And then we have the total. So I also put summation there, and then summation here. Okay. And again, here's equation 1, 2, and 3. Okay. Now, later on in this chapter, we'll look to see how we actually solve this using a calculator. But again, the goal of this first video is how do we organize this information into a matrix so we can input it into the calculator. All right, let's take a look at another example. All right, so here we have a word problem. How much money is spent if Sally buys 4 shirts, 8 pants, and 2 hats? John buys 4 pants, 4 hats, and 2 shirts, and Peter buys 4 shirts and 3 hats. And we know pants are $12.95, shirts are $14.95, and hats are $18.95. All right, so the goal is how do we figure out the total amount of money spent? All right, so let's first organize information. So notice I have a matrix set up over here. We have the person, and again, I just, labels are key here. So I have Sally, John, and Peter. And then I have the type of article that they're buying. They're buying shirts, pants, and hats. So notice right here, this data says, okay, the first person here is Sally buys 4 shirts, 8 pants, 2 hats. Now notice in this matrix controls the price of each item. So the price of a shirt is $14.95. The price of pants, $12.95, and so forth. Okay. Now what's going to happen is we are basically going to multiply these out. And again, this will be in the second video, and we get the grand total over here. Okay. So the things I want you to focus, and we'll do this in the next video on where this comes from. But what we want to focus on here is how to organize this. So let me highlight this. We have the persons over here, and then we have the dollar signs over here. So that's like we're the beginning and the end. So here's the beginning and the end, and it's the answer. So this is really what this is going to produce. Notice here we have the type and the type. Those two things are eventually going to be canceled out. Okay, so in this slide we're going to focus on how to do this. And in the next video we'll talk about how to actually multiply that. Now the nice thing is, what if there are 100 people buying 30 items? That would be, a lot of people say, well, I can just do this by hand and on my calculator. Well, if you had a lot of data and a lot of different prices, if you do it in a matrix, it takes the same amount of time. No big deal. All right, now what we have here is basically adding matrices and subtracting matrices. So basically we're taking a group of data and a group of data. Now notice here, now this is different than multiplication. Here we have rows and columns, and then rows and columns again. And here, let's say this was persons and how much money they spent Friday night and Saturday night. So over here you'd have the same people, and then Friday and Saturday night perhaps on a different weekend. So you want to say, okay, how do we add this data? Well, when we're adding data, you're looking at location. We want the location of this person and this person. How much did Peter spend on Friday night the first weekend, and Peter Friday night the second weekend? So we say, okay, if we add those two matrices together, we simply take those two locations, add them together, and you get 6. Do the same thing with -5 and 2. Add them together, get -7, and then 2 and -3 is -1, and 7 and 1 is 8. So we did the same thing over here. Now notice over here it's subtraction. See the subtraction is we're taking a group of data and subtracting a group of data. But the only thing that you have to look at is each position is only relative to the same position in the same matrix. Okay. And again, this is, let me go back to this one here. This is different because here's a multiplication problem, and this is what the next video is going to be on. And so here the order is different. Okay, because we're canceling labels. Here we're adding up labels. So here's just 3 more examples to see what we have going on here. Okay. All right, and then the last thing here, this is scalar multiplication. So this is like 3 times this set of data. So it's very simple. As if I said like 3 times the variable x, that means there's 3 x's. We're basically doing x plus x plus x. So we simply do the same thing here. It's just a scalar, a multiplier. So we just multiply through. 3 times 3 is 9. 3 times 2 is 6, 3 times 6 is 18, and then 3 times 4 is 12, and 3 times 8, 24, and 3 times 7 is 21. Okay, so really just multiplying it out. Same thing in here, we have a negative scalar, so it just gets multiplied through each position, and we get a new grand total. Okay, so that's how scalars work. All right, so here's the last example here showing why we would do that. So here we have like 3 classes: first period, second period, third period. And we have genders, male and female, and we have seniors, juniors, sophomores, and freshmen. So like in this class we have 3 male seniors and 6 female juniors. So here's the data for that class, this class, and this class. So if I say how many male seniors do I have total, we simply look at this piece of data that piece of data and that piece of data to get this total piece of data. And that's repeated for all the different positions. So this is the lovely thing about matrices. Okay. All right, so that's really what we're focusing on here for this first video, is on how to basically set up and combine sets of data.